Start recording. Enjoy. It's gonna be hot. Yeah, baby.
What kind of roast is this?
It's just the French roast.
I'm
Nothing.
so jelly right now.
Nothing fancy. My preference of coffee is the whatever's on sale at the grocery store is my favorite coffee. And people are like, no, Starbucks is the best. No, Starbucks is pure sugar and syrup.
Actually, I hate Starbucks.
And Starbucks regular coffee is pretty bad coffee.
No bueno para
In
la
my
salud.
opinion.
No bueno para la salud.
Gotcha. All right. Solving quadratic equations using quadratics, solving quadratics using factoring. We will review solving linear equations and solving quadratic trinomials, which that's what we've been working with all along, right? All right, factoring. So let's just kind of review this. We've done this a bunch. So what's my magic number here?
20.
Negative 20. So what does that tell you about the signs? One of each, right? Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Which one of those would work to add up to positive 1? 4 and 5. Which one has to be positive? The 5. So I have x squared plus 5, x minus 4x minus 20. Look here, we're grouping it, x and then x plus 5. What do I factor right here? Negative 4, very good. X plus 5. All right, so I get x minus 4 and x plus 5. If I were to FOIL that back together, it would go back, okay? And again, factoring is an awesome way of doing it. There's numerous ways to factor. What's the best way? I really like the way I do it because it goes along with something called completing the square, which is something you'll see in Algebra 2. Okay, what's my magic number here?
Negative 16.
Negative 16. So what do we know about our
Positive and negative.
positive and negative? So 1 and 16, 2 and 8, and 4 and 4. Which of those work?
2 and 8.
2 and 8. Which one's positive?
8. 2 negative, so 2
2 is positive?
Yeah.
Okay. And the 8 is negative, right? All right, so what do I have in common there?
X.
X, so I have x plus 2. What can I factor out of here?
8.
Negative 8, good. X plus 2. So this answer comes to x minus 8 and x plus 2, right? What do you think? Is that okay? And again, why do we emphasize so much on factoring? It's a logical progression of breaking apart a problem that works. And there's part of the world of math that a lot of math teachers won't tell you, but everything I've learned about math in my years of being a teacher, and this was told to me my very first year, and I can't disprove it, and this was told to me by an awesome science teacher who had went to medical school and left medicine to go into teaching, and he said flat out, math is a way for us to develop our brain to logically look at events and solve them. Logically look at events and solve them. What events? There's so many things that take place in life. That is some sort of event. And if you have the understanding of, I can logically break this down. It doesn't have to be math at all, but it's just a way of thinking. Okay? So that's pretty cool. Now you're sitting there going, well, why the heck did that guy leave medicine and go into teaching? His family was high up in the railroads. So before he even graduated from college, he was worth tens of millions of dollars. Why go work that hard to be a doctor when I can do what I love is teach? Oh, I think that's kind of cool. What about this next one? If you start having lead coefficients that aren't 1, one thing you should do is maybe see if there's a greatest common factor. It doesn't appear that I have a greatest common factor. Agree? So what's my magical number? Negative 36. So if it's negative 36, we know we have alternating signs. We got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Which one works?
3 and 12.
3 and 12. Which one's negative? 12. So I get 2x squared minus 12x plus 3x minus 18. What do I have in common there?
2x.
2x. That's x minus 6. What do I have in common here? 3. X minus 6. All right, so I get 2x plus 3, and x minus 6 is my answers. Cool. The last one. What's my magic number? -6. Alternating signs. 1 and 6 and 2 and 3. Which one's positive?
3.
The 3 is positive, so the 2 is negative. That's minus 2x plus 3x minus 1. What do I have in common here? Did you spill?
He gave you coffee. You ruined his
I
coffee.
was done with most of it anyway, so.
Corey.
I got it. Don't worry. Just
Yeah.
keep teaching.
But I give you a
Don't
new.
let-
I got a new sheet for you too.
Don't let. Okay, then. Don't let it.
Corey, come on. The only time he gives you.
Yo, I know, right? I feel so bad. Oh,
It sounded like you broke the cup too.
Behind you is the new one.
It was a nasty Corey.
All right.
Hey,
Bro, it was.
He's
good.
like, I don't want to drink Stirrups coffee anymore.
It was
I'm
good.
gonna pretend
Alright.
to spill it so.
Yeah, I checked. It was good though.
Hey, if nothing can factor it out, if nothing factors out, you got to make sure you factor a 1, right? So you have 3x minus 1, and what's the other part? 2x plus 1. Oh yeah. Okay, so that's just factoring. That's just factoring, right? It's finding that magical number, the last and the first multiplied together, figuring out all the factors, figuring out what the signs need to be, put them in there, put them in whatever order you want, make sure the signs stay correct, factor out the greatest common factor from each pair, and we go from that. That's factoring. Okay, so linear equation versus quadratic. Is there anything here?
Whoa. Magic.
Just x equal sign solved by getting x alone. What do you think? Is there some here?
I'll still help.
What?
Oh yeah. Oh yeah.
Yeah, right.
Oh yeah.
Whoa.
All right, so this has just x. This has x squared. This has an equal sign. This has an equal sign. Solve by getting x alone. Get it equal to 0. Factor and set each part, each one of your little binomial parts equal to 0. So the quadratic, when you solve it, finds you what on the parabola? The square across the x-axis. Okay. What do you think? That's all. So linear, it's a straight line. Quadratic, parabola. Ways of solving it: you can solve linear by getting everything on the other side, leaving x on one side, and you'll figure out what x is equal to for the solution. For the quadratic, you have to factor it. Sometimes they won't factor. We call it prime at this point. Okay? Irrational. I like it. So how do we solve these? This one's linear, agreed? So how would I solve this first problem? I do have a GCF, you are absolutely right, but it's linear, so what could I do just to get x alone? Do what? Add 12, right? We want x by itself, so if I add 12, and I add 12 to either side, I get 2x is equal to 26. Do you agree with that? And then how are 2 and x being held together? Multiplication. What undoes multiplication? Division. So I get x is equal to 13. Okay? What about, here, let's go down and we'll just do number 2 real quick. What do you think I should do on that number 2? So should I get rid of the parentheses first? Absolutely. So let's extend this page a little bit. So I'm going to distribute here and here. That's going to give me 6x minus 12 plus 8 equals 5x minus 9. Okay? 6x, like terms, you got it. Combine the negative 12 and the 8 together. Equals 5x minus 9. So now we need to start getting x by itself. So should I subtract 6x or should I subtract 5x? Subtract the 5x. Because you want most of the time you want to have that on the left side. That'll cancel, so I get x minus 4 is equal to negative 9. And add 4, and you'll be done. Negative 5 is your answer. X equals negative 5. Okay? But then, when we move up to the next one, we're dealing with quadratics. So I can't just start moving things over. I have to factor it in order to break it apart. Can I move off problem number 2? So, problem number 3, we have to factor it. What's my magic number? Negative 20. So I know my factors of negative 20. One has to be positive, negative. 1 and 20, 2 and 10, 4 and 5. Which one works? 1 being negative. 4 and 5. Which one has to be negative? 5. So I get x squared minus 5x plus 4x minus 20. What do I have in common here? X. And I have x minus 5. What do I have in common here? 4. And that leaves me x minus 5. So I have x plus 4 and x minus 5. Those are equal to 0. So set each one equal to 0 and solve it. X plus 4 equals 0. So x is equal to what? Negative 4. There's one answer. Solve that one. X minus 5 equals 0. Add 5 to both sides. X equals 5. That's all it is.
Is it Helen?
I think it's sleeping.
Yeah, it's
Snow and coffee. Hey, problem number 4. Problem number 4. Problem number 4. We do want to factor it, but what has to happen first? Yeah, we have to bring the 16 back on the other side. So I'm going to subtract 16 from both sides. Those cancel, so I get x squared minus 6x minus 16. Now it's equal to 0 because we moved everything over. What's my magical number? Negative 16, so I have alternating signs. And 1 and 16, 2 and 8, and 4 and 4. 2 and 8 work. Which one has to be negative? 8. Okay. So x squared minus 8x plus 2x minus 16. And that, yes, it is all equal to 0. What do I have in common here? X. That is x minus 8. And then what do I have in common here? 2. And that's x minus 8. So I have x minus 8 equals 0. And x plus 2 equals 0. So what's my answer on this one?
negative
8. So I'd have to add 8, right? And what about this one? Negative 2. And again, that's where it would cross the x-axis. Those would be your roots. If you put this as a parabola, this would be 8 comma 0, negative 2 comma 0. But that's the difference between solving the two. Solving linear, you have to just add and subtract, moving the numbers around. Distribute if you need to. But the very last step, to get x by itself, usually means you have to multiply or divide by whatever is attached to the x in order to make it work. Huh. What do you think? Did I do okay? Where are we at? There's more. Okay.
There's 4 more.
4 more.
We should do that thing again where you gave us those quizzes, like the little mini quizzes.
You like that?
Those were I like those.
Yeah,
Good for credit.
yeah, we should do that.
Okay.
Corey.
I'll get right on it. It's like, do. All right, so number 5. Let's identify it first. Is it linear or quadratic? Linear. Why is it linear? It can be equal to 0. Doesn't matter. That doesn't matter if it's equal to 0 or not.
Because it doesn't have.
What's what?
It doesn't have it's not
It
square.
It doesn't have the letters squared. So number 5 is linear because you don't have the letter squared. So let's combine some like terms. Do I have like terms on the left side of the equal sign?
Yeah.
Yeah, this and this are like terms. If I combine those together, what do I get? 10x. And then this is a minus 12. Do you agree? Now what?
Subtract the 8.
No, I want to get x
Plus
alone.
12.
Add 12. Heck yeah.
Sorry.
Come on, Gentry.
Golly, you said it too, Joseph. What are you talking about?
So we get that then, right?
Yeah.
Last step.
Divide 10.
Divide by 10. Sweet.
You don't divide the divide.
Wrong.
Sorry, Gentry.
So how many answers did that one have?
One.
1. How many answers do the quadratic ones normally have?
Two.
2. Okay. What about problem? Oh, let's go to problem number 6 first. Down here. Is that all right? Problem number 6. Is it linear or quadratic? Quadratic. What term is missing?
The
B.
The b value. Right? Okay. So sometimes when you have only 2 terms, and you happen to have your a term and your c term, sometimes, and it's separated by a subtraction sign, sometimes it might be the difference of 2 squares. But in order for difference of 2 squares to work, we need to make sure we have positive, negative, but we also have to make sure that 9x squared is a perfect square. What do you think? It is, because 3x times 3x gives me 9x squared. What about 36? Is that a perfect square?
Yeah.
6 times 6. So this problem is the difference of 2 squares. So I get 3x plus 6, and I also get 3x minus 6. Set each of those equal to 0 and start solving. Hey, let me ask you all this. This quadratic broke down into 2 what kind of problems? What kind of problem is this right now? Linear. So if you factor a quadratic, it becomes linear. All right, so I'm going to subtract 6 on this one and divide by 3, and so I get negative 2. There's one answer. I add 6 over here, right, and divide by 2. There's my answers. It was squared, 2 answers. It was a linear, 1 answer. All right, moving up. Number 7. Number 7 is raised to the 3rd power, so it's not linear or quadratic at this point. So if that happens, you might want to look for a greatest common factor. You might want to look for a greatest common factor. What do you think?
Oh,
X. I have an x in common with everything, and that gives me x squared minus 8x plus 12x, or plus 12 equals 0. So this right here is now linear. This is now quadratic. Why can I say x alone is linear?
It's not square.
It's not squared or anything, right? So if sometimes you might break down something that's to the 3rd power into a linear and a quadratic. All right, so this right here is going to be equal to 0. So I have x equals 0. That's one of my answers. That's because of this. Is that okay?
Yeah.
Now let's take this and factor it. X squared minus 8x plus 12. Magic number is 12. Negative and negative. Good job. So I got 1 and 12, 2 and 6, and 3 and 4. Which one works? 2 and 6 works, both negative. So I get x squared minus 2x minus 6x plus 12. What do I have in common here? X, and then I have x minus 2. What do I have in common here?
6.
A negative 6. So I have x minus 2 equals 0. So what's x equal to on this one? Plus 2. And I have x minus 6 equals 0. So what's x equal to here? 6. How many answers did this problem have?
3.
3.
What?
It's raised to the 3rd power. If it's raised to the 3rd power, that means you can have 3 answers.
So the A values, Whatever the A values put the number of solutions.
So whatever the highest exponent is could dictate, and I'm going to say the word could, because it's not going to be will, but it could. In this case, it did, but it doesn't always have to happen that way. But I just wanted you to know that if it's raised to whatever the highest exponent is, that's how many answers you could have with your problem. Okay? I can't make the blanket statement saying you will have, but you could have. All right, problem number 8. Problem number 8, what do you think? It's quadratic.
Oh yeah.
It is. It's raised to the second power. Is it the difference of two squares? No. 3x squared is not a perfect square. Minus 9x. Minus 9 is a perfect square. Or the 9 is a perfect square, but the x goofs it up. So what do I have on this one that might be a smidge different?
GCF.
I do have a GCF. What's my greatest common factor?
3x.
3 and an x. Agree?
Yeah.
And then that gives me x minus 3. Those are equal to 0, so I'm going to go 3x equals 0. So x equals what?
3.
X equals 0. There's my first answer. And then x minus 3 equals 0, so x equals 3. Again, 2 answers. And it works. What do you think? Bless you.
That's it.
All right, so I gotta look in the booklet. The booklet. All right, in the booklet, page 141, 142, which is solving quadratic equations. That is your assignment. Do you have these pages? I couldn't remember if you had these or not. Or is your packet done?
Yeah.
Get your packet out of homework.
They don't understand what